Grid Edge Intelligence is all about providing utilities visibility from the neighborhood transformer down to the service point and then to devices behind the meter. The most fundamental challenge the utility faces today is that they really don't have visibility at the grid edge. They have great visibility at the substation, but other than the AMI data that they're getting, which is typically hourly, half hourly, maybe 15 minutes, they're really not understanding what's going on behind the meter, so within the home, what's going on with our solar, what's going on with EV charging, what's going on with major appliances, nor do they really understand what's happening to that local transformer and how it may be overloaded. We've released a next generation smart meter that can provide far more granular information than has ever been available before. And we've also introduced as part of that meter a platform for delivering applications that can run at the edge to access that granular data. And so taken together with our communications network, we can then provide access to amazing insights that really have not been possible before. So we're starting first with visibility, so allowing utilities to understand what's going on, and then we're evolving that into planning and control. So how can you go ahead and take action on the findings that you now have? The best two examples are solar and EV charging. So with solar, in some utilities, some geographies, there's very significant solar penetration, so much so that at the middle of the day when the sun is burning bright, electricity is now flowing in reverse through the grid. But then a cloud comes over and suddenly all that solar generation goes away and now the true load on the grid becomes apparent. So providing visibility into that problem and the control to be able to go ahead and curtail excess solar becomes incredibly important. And then with respect to electric vehicle charging at home, which is really going to be the most prevalent place people charge their vehicles, what you see there is a problem of hyperlocality, where the cars are not spread equally throughout an area, but tend to be condensed into certain neighborhoods. And so then getting visibility into where the electric vehicles are and then when they are charging is really important for our planning purposes. And then to be able to go ahead and manage that EV charging either through programs that encourage consumers based upon tariffs to charge at certain times or through active management of charging become two really effective tools for addressing that problem. So what we've seen so far is they are progressing in that journey from visibility to active management and control. So these meters that have the ability to get that access to that granular information, those are deployed in the field today. They're rolling out applications that provide the visibility. And probably the most important and foundational of those applications is something we call location awareness, that allow utilities to very accurately map which meters are connected to which transformer and which phase of power on that transformer. So with that information, now the utility can accurately understand what's going on within their low voltage grid, and it can then start to progress along that journey we just discussed. It shows up in a variety of ways. So with respect to that location awareness example, there's an O&M element to this of when the power goes out, when there's a major storm and utilities are trying to restore power, they want to do so as quickly as possible. They want to do that both for the end consumer, because we all want our power to be back on as quickly as possible, but they also want to do it for themselves because it costs them a lot of money to have personnel in the field. And of course, when the lights are not on, they're not actually generating any revenue. So therefore, we can use that location awareness information to allow them to restore the power more quickly. So that's one good example. A second good example is eliminating truck rolls due to preventable maintenance issues. So if we can anticipate those issues, we can see that a transformer has been overloaded for an ongoing period of time and is at risk of failing, well, they can go ahead and replace that transformer with the right size transformer before it blows, and that causes, again, an emergency outage. As we move forward, though, really the more important opportunities are with respect to consumer engagement. Right? At the end of the day, if I want solar on my rooftop, if I want a battery in my home, if I want to charge my car at home, the utility wants to be able to say yes. And so being able to go ahead and plan their grid such that they can say yes and allow the consumer to do all those things and then engage with the consumer to manage those resources, that really is the critical next step of the journey.
So if you were to look back at the history of Itron and you go back all the way to its roots back in 1977, what you'd find is that communications and the way we've transformed the way utilities have actually operated their business has been foundational in just providing benefits. So back in the old days, technology was there to enable our customers to read their electricity meters, gas meters, and water meters by walking by the solution. That evolved eventually to being able to drive by the solution. So when you think about the efficiencies and the operational savings that are gained from just those very small steps in the process, it was monumental for the industry. As the world started to transform and really focus energies on advanced metering solutions, the requirements for connectivity really went up to the next level. We were being asked to produce solutions and networks that could cover large municipal areas, large metropolitan areas like New York City, San Francisco, Paris. And so what happened was the requirements for the connectivity went to the next level because the expectation of performance went to the next level. So now we're no longer reading these endpoints once every month. We're reading these, say, once every 4 hours. So what became interesting was that the expectations of the communications continued to rise as utilities started to see the benefits of operating their systems in a whole different way. If we fast forward to where we are today with grid edge intelligence technologies, and a lot of what Don just spoke about was the ability to have insights from each of these endpoints, the ability to identify where you are on the electrical grid, talking about the location awareness application, being able to interact with the consumer, say helping them control their distributed energy resources, is all enabled by intelligent connectivity. So whether it's Wi-Fi connectivity from the intelligent endpoint to a smart inverter or an EV charger, or whether it is the ability to connect these devices over mesh technology, cellular technology, or a combination of both. The requirements for connectivity continue to rise as there's new producers and consumers of energy at the edge of the grid, and really the importance of connectivity can't be understated because there's no other way to gain that visibility unless you have connectivity.